to keep an eye on it. And I think after I get through describing all the projects and before we jump into results, I'll make sure to take a look at chat and address any questions at that time. Just a little bit in the way of introduction to the committee in case anyone watching this is unfamiliar. The Junction Creek Stewardship Committee is a not-for-profit organization that came together back in 1999 in response to this really incredible environmental degradation experienced by Junction Creek. We're led by a volunteer board of directors and typically carry 1 to 2 full-time staff and then add additional seasonal staff during our busy times of spring and summer. And really the main goal of this group has been the restoration of Junction Creek and working to maintain that ecosystem function and health within the watershed. And so this goal is really focused around 4 main pillars: research, restoration, education, and connecting the community to the creek. And really, it's the connectivity of these goals, I think, is one of the really great strengths of the committee, using research to inform restoration efforts, working then with the community on projects like removing litter and planting trees, which really then allows us to give back and conduct educational programs and outreach events like citizen science walks and our school programs. We hope then that this kind of inspires new generations and people to take an interest in Junction Creek and the environment around Sudbury, and then maybe lead to more interesting research in the future. The real question, though, is why is the research so important? And I think this is a really important question to address, and that the answer gives us a lot of context for the types of activities that we focus on as the committee. And so really the value of consistent research and monitoring is that it allows us to see this change over time. And this is a really important concept because it allows us to react to problems as they arise and really ground all of our actions and restoration efforts in science, really allowing us to make informed decisions that can hopefully over time really benefit Junction Creek and to address that severe degradation that I mentioned. So really consistently updating our knowledge of Junction Creek by conducting research, looking at fish and bugs and measuring water quality, and comparing these results to past results really allows us to be aware of this change over time and give us an opportunity to react early to these issues or any potential issues before they grow and cause large-scale harm. So with that in mind, the more information that can be collected, so engaging in a wide variety of research and monitoring projects, the better we are able to identify either positive or negative change within the creek. And so these are the research projects that we were involved in over 2019. And the field season was a really busy one for staff at Junction Creek. Like you see here, there's 5 main research projects. And they were really a mix of continuing ongoing efforts with the water sampling, expanding on some of those efforts with litter monitoring and cleanup, and some additions to the temperature monitoring, and then updating past research efforts. With the fish community assessment and our Benthic macroinvertebrate surveys. And so jumping into the litter monitoring and cleanups, the main focus here was to identify where in the creek, if any, garbage was accumulating. So really finding those hot spots. And then after determining the types of garbage that was most common in the creek. So whether or not we were seeing food wrappers, plastic bags, drink containers, that kind of thing. And so the protocol that kind of directed this project, the surveys were all conducted by staff throughout the spring, summer, and fall of 2019. And these surveys let us identify those hotspots and help to inform the public cleanup events that we held this past year. And so you can see here on the map, these sections of Junction Creek highlighted in yellow are the sections that we held cleanups. And so In addition to the initial litter monitoring and cleanups, we also held post-cleanup surveys. So we would again go out and monitor these same sections to try to get an idea of the rate that garbage reaccumulated at the sites of the cleanups. And so the garbage tally was kind of the new component that was added to this project. Because community cleanups have always been a regular part, a regular event for the Junction Creek Stewardship Committee. But this year, with the assistance of Plastic Free Greater Sudbury, we were able to add these garbage tallies to the events. And so what was happening here was that all the collected litter was then brought back to a central location and sorted into different categories like plastic bags, food wrappers or cans, and then we tallied the full amount of those items that we would find. And so really the idea was that by improving our understanding of the different challenges faced by different sections of the creek, so the different types of litter that was most commonly accumulating in those different sections, we would then be able to tailor restoration efforts to that specific type of garbage and try to be as effective as possible with our efforts there. So jumping over to the next project, we have our expanded Junction Creek temperature monitoring program. And so this is something that's always kind of been included in our monthly water sampling, which we'll get into a bit later. But the idea here was to increase our understanding of brook trout habitat suitability throughout the creek by expanding our monitoring of the daily and seasonal fluctuations of water temperature throughout Junction Creek. And so on a broad scale, the sites were selected in order to get a wide coverage of the upper half of Junction Creek, from the headwaters in Garrison to where the creek goes underground near Matition Park. But on a macro level, the sites were selected based on a number of factors, including ease of access, employee safety, and also like how well those sites represented the area. So I should also mention that there are a few dots here off the main path of Junction Creek here. And these are some of the tributaries that feed into Junction Creek, because we also wanted to get an idea of the temperature of that water. So we used hobo pendants as the temperature loggers. They were secured to the bottom of the creek and were set to record water temperature every 30 minutes, starting June 21st. And I believe the last logger was pulled out of the creek, I think it was October 30th. So the next project was our fish community assessment. And this was really our big focus over the past summer. And the goals here were to kind of update our knowledge on the abundance and distribution of fish living in Junction Creek. And this is actually the third assessment conducted by the committee, with previous assessments done in 2004 and 2008. So additionally, this year, we were also looking at the health of the fish living in the creek. And this was part of an undergrad thesis for a Laurentian University student. And so we worked closely with Dr. Mary Martinez and her student Stephanie throughout the entirety of the project. I should also go on to mention that the project was really strongly supported by Dr. Daryl Edwards at Cambrian College, as well as Laurentian's Cooperative Freshwater Ecology Unit. And so site selection for the fish assessment was based off of protocols developed in those previous assessments. So Junction Creek was divided up into 16 individual reaches. And then within those reaches, the creek was further broken down into 100-meter survey sites. And so what we did was we surveyed every other site, either by electrofishing or through the use of minnow traps, depending on site conditions. And we traveled the entire length of the main branch of Junction Creek, from the headwaters in Garrison down to Kelly Lake. And so there was also a habitat assessment component of the fish surveys. And so at a minimum, for each site that we surveyed in the assessment, we collected water temperature, dissolved oxygen, pH, conductivity, salinity, and measured water depth. So for sites surveyed with minnow traps, this data was collected at each trap. And typically there were 4 traps to a site. And then for sites that were electrofished, this data was collected at the beginning, middle, and end of each site. And so here in the photos, you see a couple of our summer students taking those measurements. And I think this was near New Sudbury. And so in addition to those measurements I just mentioned, there were also observations made regarding substrate composition as well as riparian zone. And the other photo here, you can see 2 of our interns collecting some of that data. And so, as I mentioned, our two methods of capture were electrofishing and minnow trapping. Regardless, though, of the collection method, all the fish were processed the same. There was a mixture, a clove oil mixture, was used to anesthetize the fish, and from there, the weights, lengths, and photos were taken for the first 30 individuals of each species at each site, and this was the data that was used to determine fish health. And so here you can see a bit of that process. We have a combination of staff, project partners, as well as placement students, kind of working together to take those measurements. Moving on to the Benthic macroinvertebrate surveys, and just really quickly for anyone unfamiliar with the term, these are invertebrates that live at the bottom of creeks, lakes, and rivers. Typically, they're long-lived and relatively static in the environment, so they don't move around too much. And because different species exhibit different tolerance levels to pollution, the presence or absence of these creatures can really tell us a lot about the health of individual sections of Junction Creek. And so all of these surveys followed protocols set out by the Canadian Aquatic Biomonitoring Network and took place from September to November. A total of 8 sites were surveyed in 2019, and the sites were selected based on a combination of factors. So areas where historical benthic surveys had already occurred, as well as other areas of interest to the community. And yeah, so all the collections were carried out by cabin certified staff members, utilizing a kick and sweep method. And as I mentioned, took place from September to November there. All the collected samples were then shipped off to the University of Guelph for eDNA analysis. And the final kind of research monitoring project that we had going on last summer was our water sampling. And the water sampling has been going on for the past 15 years. And throughout that whole time, it's been supported by the City of Greater Sudbury, as well as Valet, who've provided in-kind support, analysis, as well as continuous funding for all that monitoring. And so this monitoring takes place at 10 sites throughout Junction Creek and its tributaries, kind of between the headwaters in Garrison and the creek's outlet to Kelly Lake. And at each site, water temperature, conductivity, and depth are measured, as well as 3 water samples are collected. And you can see those bottles, the collected bottles down here in this lower photo. And Valley's lab, the samples are brought to Valley's lab for that analysis. So just before I jump into some of the results, was there any questions so far about the protocols or what we were doing with any of the projects? Okay, I don't see anybody typing, so I'll continue on. If questions do come up, don't hesitate to send them over in chat. Let's switch back to this. Okay. So starting back with the litter monitoring and cleanups, looking at the map here, you can see some of the results with the creek color-coded based on the presence or absence of garbage and how quickly that garbage reaccumulated after cleanup. So we see in those the green, yellow, and orange sections that really the majority of Junction Creek either has no litter, has a small enough amount of litter that it didn't require a cleanup, or that the litter didn't accumulate again after a cleanup was held, which is really cool to see. Some of the areas of concern, though, or areas to note, were New Sudbury, the Flour Mill, and the Gatchell area. And so those are sections where we see highlighted in red and black, where garbage reaccumulated to near pre-cleanup levels within a month of that cleanup for those red sections, and then the black section, garbage reaccumulation happened in less than a week. And so just to dive into those sections a little bit, the litter found there was mostly comprised of plastic wrappers and bags, but we did see rather a little bit of variation with more plastic bottles in the Gatchell area, and then larger furniture items throughout the flour mill. All in all, though, I think this is a really promising result. It shows that after the 11 cleanups and more than 2,500 kilograms of garbage that was removed from the creek, a great amount of that work really did provide lasting benefits to the areas, which is really nice to see. So looking now at the Junction Creek temperature monitoring, there's a lot going on, but the graph in the middle here shows the mean daily water temperature throughout the summer compared to brook trout temperature preferences, which are those colored bars in the background. And so that green section is the optimal temperature range for brook trout, which is 11 to 16 degrees. And the top of the yellow section above that ends at the upper tolerance limit, which is 20 degrees. Beyond 20 degrees, brook trout are really severely impacted, and it wouldn't be able to tolerate living in conditions like that for long. The chart on the right there shows kind of some similar information, just breaking down the percent of time that each logger site had water temperatures in different temperature range categories for brook trout. So we see that optimal range of 11 to 16, non-optimal, anytime temperatures were outside of that range, and then the percent of time water temperatures were below 20 degrees and then above. So what we're really seeing here is that there's quite a bit of variability in water temperature throughout Junction Creek, and that there are sections of creek that are not currently well suited for brook trout. I think, though, the important takeaway is that while we do see water temperatures up into and through those yellow and red bars, kind of showing that temperatures aren't really well suited to trout, there are still areas where temperatures are more reasonable for the trout, and they're likely providing a lot of thermal refuge for the trout during those warmer summer months. And so just quickly looking at temperature profiles for some of the individual sites, we see on the first graph here, comparing the Junction Creek average to the temperatures measured in Garson, with Garson temperatures being quite a bit higher than the average. Moving downstream as we get into Twin Forks area, which is the coolest area of Junction Creek that we're measuring, and then flowing beyond Twin Forks back towards downtown and where the creek goes underground, we see the temperatures start to rise again. And again, with the limited number of loggers that we had, not really convinced that we have a full understanding of the temperature profile of the creek yet. And just to back that up, some of the measurements that we did take during the fish study seemed to indicate that there were some cold water seeps in the upper sections of Junction Creek that are probably providing relief to those cold water species like the brook trout, and that they would likely congregate there as the water temperatures rose. So moving on to the fish study, we have seen a lot of positive changes when comparing the results to the past studies. Just to start with our results, though, for this year, we surveyed 114 sites, which is approximately 11.5 kilometers of creek. We captured and tallied nearly 10,000 fish over the course of the summer and recorded 17 species, one of which, the log perch, had not been previously recorded in the creek. And so this big chart on the right-hand side here just shows a breakdown of the species that were caught during the study. And you can see the vast majority were creek chub with nearly 60% of the total catch, followed by northern red belly dace, which isn't there, but it's this marker here. and common shiner with just over 7% and 5% of the catch respectively. So in regards to the fish, one of the quality measurements we really looked at was the presence or absence of fish that were intolerant to pollution. So meaning that those fish require clean water and high quality habitat to survive. So we see here in this graphic at the bottom of the screen, all the species recorded in the study grouped by their tolerance to poor habitat conditions. And one of the really exciting things about finding log perch is that they're classified as a sensitive species, kind of requiring that clean and healthy water. And so we can have them join the brook trout and the black-nosed shiners as species residing in Junction Creek that are intolerant to pollution. And so looking at the creek under this lens of presence, absence of sensitive fish species, we can kind of get an idea of how Junction Creek changes in quality as it flows through Sudbury. So looking at the map here, in areas where the creek is colored blue or green, we see that there are sensitive fish species present. And then areas with the brown coloring are spots where there are no sensitive species found. And so looking at this change over time, we see that there's a steady kind of increase in the presence, the diversity of fish within the creek. Looking at the original study in '93, saw 10 species recorded in the creek. Comparing that to the 17 that we found in 2019 is really a great thing to see. And then additionally, looking at our sensitive species again, at this bottom left-hand graph here, we see that not only is there a greater variety of them, but that their distribution within the creek is also increasing. Just focusing on the black-nosed shiners, there are none found in 2004. 2008 found them in 2 reaches, and now we found them in 6 reaches this past summer. So another really, really cool result. Okay, so just moving quickly to the macroinvertebrates. Unfortunately, we're still awaiting results from those surveys. The eDNA processing is being completed, like I mentioned, by the University of Guelph, and that's been slowed down due to complications from COVID-19. But hopefully we'll receive those shortly. For 2020 though, we're hoping to expand the number of sites that we surveyed and look at a few different areas, including some of the tributaries, just to get a better idea of what's going on in the smaller creeks flowing into Junction Creek. And then finally, looking at the monthly water monitoring, we've very recently received analysis, a detailed analysis of the past 15 years of that monitoring, and those results will be shared really soon. Generally though, we've seen really broad improvements across the majority of Junction Creek, and the measured elements and compounds that we're seeing now, the levels rather of those elements and compounds, are generally in line, seem to be in line with both the provincial water quality objectives as well as the Canadian water quality guidelines, which is a really nice thing to see. And so, like I mentioned at the beginning, I think the real value from carrying out a variety of research projects and kind of maintaining those long-term monitoring in the creek is being able to take all the results and put them together to get a more comprehensive picture of Junction Creek. So looking at both the fish study and the litter surveys, for example, we can see multiple areas of concern where there are no sensitive fish species or where there are high levels of litter that are accumulating. In addition to that, though, we can also pinpoint those areas where we're seeing really exciting results from past restoration efforts. So like sections where there are multiple species of sensitive fish and where there are little to no buildup of litter. And so when combining those results and taking into consideration some of the other data we have in regards to water temperatures and water chemistry, it's really shown a lot of great improvements and we get to kind of really see a nice picture of both the areas that have recovered nicely over the years and benefited from those restoration efforts, as well as the areas that could use a little more attention moving forward. So here we see areas where there's a lot of litter accumulating, as well as the absence of sensitive fish and some of the poor water quality conditions, and then as well as sections where there are no litter present, really high, nice cold water, as well as presence of multiple species of sensitive fish. And so knowing about both of these types of areas along Junction Creek really allows for tailored restoration efforts to address those specific challenges. And just to finish up shortly, I think there were really just a few important takeaway messages from the 2019 projects that are kind of important to highlight. So first being that long-term monitoring and reputable research projects are really critical to our understanding of the health of Junction Creek. They really allow us to monitor that change over time and identify areas that are responding well to restoration efforts, as well as those areas that kind of need extra attention. And so this is kind of the backbone of how we can make science-based decisions in regards to the restoration of Junction Creek. And so the next, I think, a really important message is that there's a lot of success in collaboration. All of our projects are based on collaborating with multiple parties and sharing resources, whether it be time, expertise, or financial resources. And really, it's at the heart of the Junction Creek Stewardship Committee. It's based on coming together, on the coming together of people from different backgrounds and with different resources to do a lot of great work in the community, more than anyone could do individually. And so the next really cool thing is that Junction Creek is definitely improving. We see this kind of in a lot of different ways: decreased pollution levels, long stretches of the creek that are litter-free, the increasing distribution of organisms like fish that are sensitive to poor water quality. And so there's a lot of good things happening in the creek that I think we wouldn't have seen a few years ago. That being said, there are still degraded areas. And so, yeah, while the creek has seen improvement over the years, there's definitely still lots of work to be done. But really, by maintaining that research and monitoring, we really do expect to see that the restoration efforts will continue to be impactful and really promote positive change within Junction Creek. And so really in closing, if you're interested in any more information on the committee or just getting involved in the future, definitely be sure to check out our social media pages. You can also join our mailing list. If you're interested, you can go to that link, junctioncreek.com, and scroll down to the bottom of the page and subscribe. I also just wanted to leave you with a really quick friendly reminder to always try and be creek friendly by doing things like not littering, picking up after your pets, not putting anything down storm drains, and trying to choose non-toxic household products if possible. And so finally, I'd just like to really quickly acknowledge everyone who's been able to take part in the Junction Creek research efforts this past summer. We had a lot of really, really excellent partners, and I can't thank them all enough for all their hard work and support through the year. And so with that said, I just want to say thank you very much to everyone who's stuck it out this far and listened to the presentation. I know it was a really brief, high-level overview. I could probably talk about this stuff for a couple hours, but yeah, just wanted to give you a quick idea of what's been going on and kind of preliminary results from that work. So we can take any questions now if anybody had anything they wanted to clarify.
Brandon, just so it doesn't get too long, I'm going to stop the recording.
Yeah, that sounds good, Peter. Thanks.
Yeah.